question 9. So the first one asks us the maximum number of students in the sample who on average have read more than 100 minutes per day. So what the table means is that 16 of them read between 0 and 30 minutes, and 35 of them read between 30 and 60 minutes, and 62 read between 60 and 90, and so on. So we don't know exactly the amount that these 16 read. We just know that each one of them read somewhere between between 0 and 30 minutes. So there could have been a lot of that 16 that read maybe 1 or 2 minutes, or there could have been most of them maybe read above 25 minutes. We don't really know the breakdown of the 0 to 30 minutes. So that's what this grouped frequency table means. So the maximum number of students then that could have read 100 minutes per day. So 100 minutes would be in this one here. So these 59 students, they might have read more than 100, they might not have. But for example, all those 59 might have only read between 90 and 100, but they could also have read between 100 and 120. So for the maximum number possible, we're going to assume that all of those 59 read above 100 minutes. So we're going to include that. So it'll be 59, and then these 18 have to count anyway because all of those read between 120 and 150. So we're going to include those, so plus 18 and then plus 10. And then we're just adding those three things together. So you get 87 there. Then estimate the median time spent reading by the 200 students. Right, so for median then, so median would be the middle one in the list. So if there was 200 students written out, so just so we had 200 students and we had the amount of times they read listed out in a straight line, the median will be the one in the middle. So because there's 200 students, the median is going to be the 100 student in that list. So the first 30 students first 16 students in the list would all have read between 0 and 30. That's the first 16. But then the next 35 then, so that would get us up to 51 students, because 16 and 35 is 51. So then there's another 62 then that read between 60 and 90. So that would take you up to 113 students. So now you've passed the 100 one. So the 100 one has to lie in here. So between 60 and 90. Now we don't actually know that 100 student. We don't know how those 62 students were spread out between the 60 and 90 minutes. So, but if we're taking an average, we'll just go with what's in the middle. So the middle of 60 and 90 will be 75 minutes. So we're just assuming that maybe that all those 62 students were kind of evenly spread out between 60 and 90, that some of them took 61, 62, all the way up to maybe 88, 89 minutes, and that they were all kind of evenly spread out between there to get the best possible average. Right, so for this next one then, so why does choosing this method of choosing students influence its validity? So if you go back to the top of the question, it's to investigate the average amount of time that students in Ireland spend reading each day. So they asked 200 students who came into their school, so it's only one school that they're taking it from. So only one school is one reason anyway. So that could be a school where all the students are really, so it could be a really top school where students are just going to read a lot every day, or then it could be a really maybe disadvantaged school where students maybe might not read that much, so that you can't really take one school for the context of the whole country, of students in the whole country. So only one school, and then it's only 200 students as well. So based on something off 200 students for every student in Ireland would influence the validity of the conclusion. So something to that effect. Right, the next one, you have to put it on a grid. So you're just putting all these values onto it then. So easiest thing is to use a histogram. So draw a graph or chart. So it doesn't say exactly, but the easiest one to use is a histogram. So it looks like a bar chart, but all the bars are together, and it's always for between values. So it'd be something like this. Now you have to use a ruler and measure it properly, but so you see it goes from 16 there up to 59. So if we go up in 10, so 10, 20, 30, 40, and so on. So then the first bar you would put down between 0 and 30. And then the next one would be between 30 and 60. And then 60 and 90. And then up to 120, 150, and 180. So you're just putting up the bars then. So the first one is 16, so it'll be about here. So use a ruler now when you're doing it. But roughly it'll be something like this. And then it goes up to 35. And then 62. I did it wrong again. 59. And 18. And 10. So it should look something like that. So you should be able to do it a little more accurately if we're using a ruler and measuring it out. So that's how you put it on the table. Right, so part B then, so a random sample of 500 students in Cork took a statistics test. 61 of them were given a rating of excellent. So work out the percentage of students who were given a rating of excellent. So it's just 61 out of 500, and then we multiply it by 100 to give us a percentage. So that's 12.2% when you use calculator. So show that the margin of error. So margin of error is 1 over square root of n, where n is the population, or it's the number of people that are in the sample. So people being tested is probably more accurate. So that will just be 1 over square root of 500, because there's 500 for this test. So you get 4.5% there when you round it off. So you have to round it off to the nearest, yeah, so yeah, it tells you anyway in the question. You just had to show that it was that was the margin of error. Okay, part 3 then. Right, so the third one is a hypothesis test. So it doesn't really say hypothesis test in it, but we have to do it anyway. So our null hypothesis would be 10% of students get excellent, and our alternative hypothesis then would be that 10% don't. So then we're going to do our proportion plus or minus the margin of error. So now our proportion is just going to be the first thing we calculated up here, so that's the 12.2%. So I'm just going to change that into decimals, so 0.122 plus or minus, and then the margin of error was 4.5%, so that would be 0.045. And then we're just going to do it with a plus and with a, so we're going to do 0.122 minus 0.045 and then do 0.122 plus 0.045, and that will give us our interval then. So we get 6.7 and 16.7 percent, so I converted them back into percentages. So therefore we're going to fail to reject, because the 10% is in between those then. 10% is easily between 6.7 and 16.7. So fail to reject the null hypothesis. So because 10% lies within the confidence interval, so that's it then, that's all for that question.